Welcome to this explainer. Today, we're looking at something literally out of this world. I'll be your guide as we examine the sheer, unbelievable ambition of the Artemis III mission, which is set for 2027. Now, I want to be clear. This isn't just another routine flight. This is our carefully planned return to deep space. So let's break down exactly how humanity is gearing up to go further than we've been in over half a century. Okay, let's dive into this. As NASA Administrator Jared Isaacman so perfectly puts it, we're ushering in a new golden age of exploration. And I really want to emphasize that right up front. This mission isn't just checking boxes on a test flight. It's the dawn of a whole new era. We're taking the epic dreams of the Apollo generation and bringing them into a completely modern context. Here's our roadmap for the journey today. We'll start with the next giant leap, check out the lunar hardware, break down the multi-launch logistics, meet the crew, and wrap up with our stepping stones to Mars. Let's get into it. Part 1, the next giant leap, focusing on the 2027 Earth orbit test flight. So, what is the core objective of Artemis III? Well, it's all about executing a highly challenging series of tests right here in Earth orbit. Think of it as a massive, high-stakes dress rehearsal. The primary goal is demonstrating rendezvous and docking capabilities in low Earth orbit. The logic here is actually pretty simple. We absolutely have to ensure that every single spacecraft system talks to each other and works flawlessly in the relative safety of Earth orbit before we even think about launching the Artemis IV crew to the lunar South Pole in 2028. Moving on to Part 2, building the lunar hardware and how we're taking this from concept to reality. So the crucial point is that this hardware isn't just theoretical anymore. It's rapidly moving from engineering blueprints into massive physical reality this very summer. Engineers are out there actively connecting the Orion crew and service modules. They're integrating its first flight docking system. We've got vital ultrasonic testing on the heat shield underway. Plus, the absolute behemoth that is the SLS rocket is being stacked as we speak, combining the engine section with 4 RS-25 engines. Oh, and the solid rocket booster segments, they're already staged down at NASA Kennedy. It's like a giant puzzle, and the pieces are coming together right now. Now, when it comes to the commercial human landing systems, NASA is playing it smart with a dual approach. They're working hands-on with both Blue Origin's Blue Moon and SpaceX's Starship simultaneously. They're sharing all of their deep agency expertise as both of these companies race to build specific test articles for this Artemis III mission. That brings us to Part 3, a choreographed space ballet, where we'll look at the multi-launch logistics. The operational logistics here are, frankly, mind-blowing. We're talking about a multi-launch campaign. By definition, that's a dramatic sequence of heavy-lift rockets designed to test integrated hardware, software, and propulsion between multiple spacecraft in orbit. We aren't just launching one single capsule and calling it a day. No way! This requires a level of coordination across the global spaceflight community that we have literally never seen before. And this brilliantly illustrates how it all goes down. Over a roughly 2-week orbital sequence, we're basically going to watch an incredible relay race. Step 1, Blue Origin's Pathfinder launches and waits up in orbit for multiple weeks if necessary. Step 2, the massive SLS rocket launches the Orion spacecraft and its crew. Step 3, Orion meets up and actually docks with the Blue Origin lander for about 2 days of intense testing. Step 4, SpaceX's Starship launches, rendezvous, and docks with Orion for another day of checkouts. Finally, Step 5, Orion undocks, heads home, and safely splashes down in the Pacific Ocean for Navy recovery. It's a highly choreographed ballet happening entirely in the vacuum of space. All right, Part 4, meet the Artemis crew. Let's talk about the human element. Executing a test flight this daring requires some highly specialized individuals. Up there, we have Randy Bresnik serving as commander for NASA, Luca Parmitano as pilot from the ESA, Andre Douglas and Frank Rubio serving as mission specialists from NASA, and Bob Hines stepping in as the crucial backup. This team draws on absolutely incredible talent, and really importantly, it cements a vital, enduring international partnership for the entire Artemis program. Now, what's really interesting about this slide is the number 1. Pilot Luca Parmitano is the very first European Space Agency astronaut to ever be assigned to an Artemis mission. That is a massive milestone. It really reflects the deep European expertise in human spaceflight, which makes total sense, considering ESA actually provides the critical European service module that powers the Orion spacecraft. Next up, we have the number 7,000. That represents Commander Randy Bresnik's astonishing flight hours across 95 different types of aircraft. I mean,
Wow. As a retired U.S. Marine colonel and a veteran of multiple space station expeditions, he brings massive operational experience to the table. When you're up there testing multiple brand new spacecraft in orbit, this is exactly the kind of seasoned leadership you want at the helm.
And consider 371. Mission specialist Frank Rubio holds the American record for 371 consecutive days in orbit. Spending over a year in space proves his extreme physical and mental resilience. Having a medical doctor and an Army aviator who has proven he can thrive in space for that long, that's an incredible asset to this crew. Rounding out the primary crew is mission specialist Andre Douglas. Now, actually, scratch that thought about seasoned space veterans for a second, because this will be his first spaceflight, but he brings vital expertise in multi-domain autonomous vehicles and systems engineering from his time at the Johns Hopkins University Applied Physics Lab. For a technology-heavy mission that's hyper-focused on complex automated rendezvous and docking software, his deep technical background makes him a crucial piece of the puzzle. Let's move to part 5 and see how this builds towards the future. Stepping stones to Mars, looking at the horizon. Let's put this all into perspective. In April of 2026, we saw the successful completion of Artemis II. Now, sitting right in the middle, we have the 2027 Artemis III Earth orbit test. It acts as the absolutely indispensable bridge to the Artemis IV Lunar South Pole landing, which is targeted for 2028. You see, everything is happening in a very calculated step-by-step sequence. So why does all of this matter to us? Because this is about what's beyond the moon. We're talking groundbreaking scientific discovery, massive economic benefits, establishing an enduring human presence on the lunar surface, and ultimately building the foundation for the first crewed missions to Mars. We aren't just testing rockets in orbit just for the fun of it. We are laying down the actual infrastructure and operational knowledge to eventually push humanity all the way to the red planet. Which leaves us with this final provocative thought. If Artemis III conquers Earth orbit and perfectly executes these impossibly complex docking maneuvers in 2027, what incredible things are we going to discover when we finally touch down at the lunar South Pole in 2028? It's an absolutely awe-inspiring time for spaceflight. We really are entering a new golden age of exploration, and I hope this explainer has left you eager to follow along as humanity takes its next giant leap.